Okay, today we're going to do the product rule. We're going to do the proof and the examples in one lesson. And this is the product rule for derivatives. Now remember, the word product means multiply. So we're going to be multiplying two functions together. We're going to figure out what the derivative is. I can't stress it enough. What is the derivative? The derivative is the slope of the tangent line, right? It's the instantaneous rate of change. We want to keep using these terms just to refresh our memory. Suppose we have a function like f of x equals 3x squared times sine of x. How would we find f prime of x, the derivative? In other words, f prime of x is an equation which, when you plug an x value into that equation, that gives you the slope of the tangent line at the x value for the original function. So we haven't learned this yet, right? What happens when you have two different functions multiplying each other? How do you figure out its derivative? Since it's a product, we're going to learn the product rule. So here's the proof. Let's write p of x, meaning the product of two different functions, equals f of x times g of x. So we have a new function equal to the product of two different functions, just like in this previous slide. By the definition of the derivative, we have the following. This should say p. Let me fix that real quick. Okay, so we have p prime of x equals the limit as h approaches 0 of p of x plus h minus p of x over h. So we first need to figure out what p of x plus h is, but we've defined p of x as f of x times g of x. So p of x plus h is just f of x plus h times g of x plus h. Then we will replace p of x with f of x times g of x. That's going to look like this. So here's our p of x plus h, and here is our p of x. Now, the way this proof works is kind of strange. We're going to end up adding two terms that weren't there before. It's kind of weird, but it's kind of like the reverse of, how can I say it? It's kind of like the reverse of the conjugate, now that I think about it. When you multiply something by its conjugate, the two middle terms cancel. What we're doing with this proof is we're inserting two middle terms that will cancel each other out. So in other words, we're inserting minus f of x plus h times g of x plus f of x plus h times g of x. These two terms will cancel out, and they will give us what we started with. Okay, and this is kind of small. You might have to zoom in. Why are we inserting those two terms? Well, we want to come up with a proof for the derivative of p prime, the product of these two functions. And so you're going to begin to see why we did that. Now, when we insert minus f of x plus h times g of x plus f of x plus h times g of x, we need to do a little bit of regrouping. So the first thing we're going to do is we're going to pull an f of x plus h out of both of these terms, since they both have an f of x plus h. When we pull this f of x plus h out, we're left with g of x plus h minus g of x. So I said regrouping. What we're really doing is we're kind of factoring. So we're pulling the GCF of these two terms out. Both of these terms have a g of x, so we're going to pull this g of x out. In fact, let me just do some underlining here so you can see this proof. So for up here, we're pulling this f of x plus h out. For this particular step, we're pulling a g of x out. When we pull them out, we get this. Okay, so now we have this expression. What do we do now? Well, I'm kind of going to pull this f of x plus h all the way out and then write the second part as g of x plus h minus g of x over h. You should be able to recognize that as basically the derivative of g, right? This is the definition for g prime of x. In the same way, we can pull this g of x out, and we're left with f of x plus h minus f of x over h. We're just taking each of these and dividing by h. We're allowed to do that. So this would be the definition of what? F prime of x. So we're getting closer to figuring out what our derivative is going to be. So what's the next step? The next step is, okay, so for this next step, what we're doing is we are breaking it down even further. We're going to break it down into two separate limits. And again, we can do this because of our limits laws. So this is going to be the limit as h approaches 0 of f of x plus h times the limit as h approaches 0 of g of x plus h minus g of x over h. The next one we're going to break up into two limits. The reason we do that is because, guess what? This is just the derivative of g prime, and this is just the derivative of f prime. So now we have something simpler. Limit as h approaches 0 of f of x plus h times g prime of x, plus the limit as h approaches 0 of g of x times f prime of x. Now notice something though right here. If h is approaching 0, we can plug in 0 for h and we get f of x back. In the same way, we can plug in 0, well actually, yeah, for this one, the limit as h approaches 0 of g of x is just going to give you g of x back. There's no h to plug in. So when we plug in 0 for the first one, it becomes f of x. The second one, again, the limit h approaches 0 of g of x is just g of x. And now we have f times g prime plus g times f prime. Now I like to reorder this a little bit. I like to kind of actually put this first and put the f prime first, so it's f prime g. Whoops. Okay, so let me underline this just to search. So we're going to put f prime and then f prime there, and then the g next, and then after that, I'm going to put f and then g prime. Now why do I do that? So that I can simplify it to this, and the way we read this is f prime g plus f g prime. And if you say f prime g plus f g prime enough, it'll become solidified in your mind. This, in a nutshell, is the product rule. If you're given an original function, let me see if I can blow this up a little bit, whereby it is a product of two separate functions, the derivative is f prime g plus f g prime. This is, this is the product rule, okay? I said I was going to do one video. I'm going to do two separate. So we'll just leave this as the proof of two different functions. In the next lesson, we will apply this product rule.